Most users see authentication as a cumbersome process. Therefore, it would be a good idea to reduce the number of times a user has to authenticate. Regarding web applications, the authentication cookie is the solution that enables users to download several web pages without authenticating for each page. Single sign-on (SSO) can be seen as a solution that generalizes this concept of authentication cookie. Try to imagine an authentication token that would allow you to access to several web applications in different domains. That's the idea behind SSO, allowing users to authenticate once and to access to several services and resources without the need to authenticate again. Single sign-on (SSO) is an authentication process that allows the user to access multiple resources or applications after providing his credentials only once. SSO is very useful in corporate networks where users authenticate once and access the various resources of the local network without authenticating again. The general scheme of a SSO system is the following. The user logs in by using his credentials, and if authentication is successful, he obtains a software token from a trusted third party. And this token will seamlessly authenticate him to the applications of the local network. In this video, I will present a very specific but very widely used SSO system, which is the Kerberos system. Kerberos is a SSO protocol that was named after the character Kerberos from Greek mythology. Kerberos is the ferocious three-headed guard dog of Hades. Hades is the god of the dead. Kerberos is the default authentication protocol for authenticating to a Windows domain. Kerberos protocol is not easy to present because it requires several steps using several cryptographic keys. Before I start presenting this protocol, try to have in mind the different entities involved in the protocol and the different keys. And I will describe the case of a user who, by authenticating once, obtains an authentication ticket that allows him to obtain authorization tickets to various resources, for example, a file server. So basically, the authentication server delivers the authentication token, and the ticket granting server delivers the various authorization tokens. The user will share a symmetric key between each of the other entities. And there is one key shared between the authentication server and the ticket granting server. It is the red key. And one key shared between the ticket granting server and the file server. It is the violet key. So first, the user enters his credentials on the client computer. And the client computes the blue symmetric key from the user password. Then the client sends a plain text request including the user ID. From the ID, the authentication server retrieves the user password from a directory using the LDAP protocol. And the authentication server independently computes the blue key from the retrieved password. The authentication server sends the ticket granting ticket, TGT, encrypted with the red key to the client. This red key is shared with the ticket granting service, as we will see in the next slide. The client cannot decrypt the content of the TGT since it doesn't have the red key. The TGT includes the green key, a validity period, and the user ID. The authentication server sends also to the client the green key encrypted with the blue key. And we will see the use of this green key in the next slide. The client decrypts the green key and saves the TGT. So at this step, the user is authenticated. He will not authenticate again, at least during the validity period of the TGT. The TGT is the authentication token that the client will provide to the ticket granting service whenever the user wants to access to a service. Suppose the user wants to access to the file server. The client sends the TGT as such and the ID of the requested service to the ticket granting service, TGS. The TGS decrypts the TGT. This gives the green key and the user ID to the TGS. The client sends the user ID and the timestamp encrypted with the green key. The TGS decrypts the user ID with the green key and verifies that it matches the ID that was in the TGT. So at this step, the client has authenticated to the TGS. The remaining steps are for authorizing the client to access to the file server. The TGS sends to the client the file server token encrypted with the violet key. And this violet key is shared with the file server, as we will see in the next slide. The client cannot decrypt the file server token since it doesn't have the violet key. The file server token includes the orange key, a validity period, and the user ID. The TGS sends to the client the orange key encrypted with the green key. And we will see the use of this orange key in the next slide. The client decrypts the orange key and saves the file server token. So at this step, the user has been authorized to access to the file server. The file server token is the authorization token that the client will provide to the file server whenever the user wants to access it. Now the user wants to access to the file server. To access to the file server, the client sends the file server token to the file server. The file server decrypts the file server token. This gives the orange key and the user ID to the file server. The client sends to the file server the user ID and the timestamp encrypted with the orange key. The file server decrypts the user ID with the orange key and verifies that it matches the ID that was in the file server token. And at this step, the client has authenticated to the file server. And the file server provides the requested service to the client, and that's it. This is how Kerberos works. I showed you everything except a few small details. The TGT is an authentication token which proves that the client has successfully authenticated. The client may present it to the TGS every time it needs access to a service, if the TGT has not expired. The file server token is an authorization token which grants the client access to the file server. The client may present it to the file server every time it needs access to the file server. In the Kerberos terminology, authentication server and ticket granting server form the key distribution center, a trusted third party on which the security of the Kerberos protocol is based. If the key distribution center is compromised, the security of Kerberos collapses. Over time, Kerberos has proved to be a robust protocol. That's why it's still widely used. Before the conclusion of this video, let me briefly mention some other SSO systems or authentication delegation systems. The Security Assertion Markup Language, SAML, is an open standard for exchanging authentication and authorization data between parties. And the SAML web browser SSO profile describes an SSO system allowing web applications to delegate the user authentication to an identity provider. OAuth is a protocol to delegate authorizations to third parties. It is used by companies like Google, Facebook, Twitter, and so on to allow users to share information about their accounts to third parties. OpenID Connect is based on OAuth and is for authentication delegation. Any website that offers you to authenticate via Facebook or Google implements OpenID Connect. So in this video, I presented single sign-on through one use case, the Kerberos system. This SSO system is the most widely used SSO system in corporate networks. One thing that you may have noticed is that the Kerberos protocol organizes the sharing of certain symmetric keys between the client and the other entities. And these key exchanges are not based on asymmetric cryptography and the Diffie-Hellman protocol. For your information, Kerberos key exchange is based on the Needham-Schroeder protocol, which aims to establish a session key between two parties using a trusted third party.